Sweet. So, hi everyone. My name is Zach Prater. I'm part of the Ecosystem Growth team, and we're going to be presenting Cartesi Werewolf. Next slide. So these are our teammates. Zhu did the front end. Steven did the back end. I pretended to do stuff. I worked on the PowerPoint, and Carmen kind of did everything else. She did design, and she made everything look really pretty. All right, so let's get into what exactly is Cartesi Werewolf. So if you played the game Werewolf, it's a very fun and exciting board game and card game. It brings anger and excitement to friends and family. My favorite is the anger that it brings to friends and family. It's always more comedical. So in our build, we built a fully decentralized version of this game that runs on Cartesi's Rollups that gives guaranteed transparency for the game logic and makes sure that no one else can and make sure that there's a deterministic game result that anyone can verify by running it in a Cartesi node itself. So next is gameplay overview. I think that's still me. So the gameplay overview, Werewolf has a lot of different rules, and so this will be a very simple game. It will be one moderator, one werewolf, and 4 villagers, so a game of 6. And in the next slide, we will just kind of show you the front end and explain how everything works. So demo time. Steve and Zhu, are y'all gonna give the demo? Oh, sweet.
Yeah, I'll give the demo.
Sweet.
Thanks, Zach. So can everyone hear me?
Yeah.
Okay, so we're playing a demo video that the earlier image that you saw was this one, the back end, and all the containers running the Cartesi rollup in front. And the other 6 little boxes you saw was the players. As we said earlier, there are 6 players and 1 moderator, as is highlighted now, 1 werewolf, and 4 other villagers. So they joined the game by submitting the public key of a pair of RSA key that they generated beforehand, so that the public keys can be used later for communication and for verification as well. So once the moderator, actually the back end receives all 6 players joining the game, receive their public keys, it will select 1 to be the moderator, and the moderator is supposed to distribute the roles to everyone else by encrypting the roles with their public keys, so that the roles are only known to the player themselves. So this game process is going a little bit fast. I think we speed it up a little bit. Can you pause a little bit, Carmen? Yeah, so I can follow up. Yeah, so as you can see from the log, there are a few rounds of the game. So first, the night comes, the werewolf will come out and select a victim to kill. So you see the right bottom is the werewolf, and he select 1 of the players to kill. And everyone else should also send their inputs to the back end, although they're villagers, so they basically do nothing, but it would be very obvious if only the werewolf make the move. So the moderator collect all the moves that are stored in the backend, which are encrypted, but they're encrypted with the moderator public key. So the moderator is able to decrypt it and verify like everyone is doing things honestly. And he'll send the move to backend in plain text. So moderator is the critical role in this game. He's supposed to push the game moving forward, but also operating correctly. Please resume, Carmen. So after a victim is being killed in the night, the remaining players vote for suspect werewolf and try to eliminate him. If the werewolf is died in that round, then the game ends. The vote session is done in plain text because there's no need to encrypt it. And okay, I can pause the video. Yeah. So yeah, the game moves pretty fast. They fail to identify the werewolf, and the werewolf wins. So you can see the entire game flow is it is executed in the Cartesi machine that have our backend logic, and all the moves are going through the blockchain if necessary, but encrypted. So this encryption ensures that everyone's privacy of their role and of their moves. But in the end of game, when they reveal their private key, they'll be able to replay the game logic and verify the result. And if there's someone playing dishonestly, they'll be punished. There can be a lot of financial layer adding on top of it, and it's still fun. So yeah. I'll hand it to the next person. Thank you.
Yeah, so I'll take crypto. Machine.
Yeah, Carmen, your sound's cutting off for me. Do you want me to do this slide?
Okay, yeah, if it's cutting up. Go ahead.
Sure. So, everyone, so wrapping things up, we just kind of wanted to explain why Cartesi and then what actually happens after the hackathon. So for why Cartesi, a lot of times for us it was the cryptographic library that we used, which is currently not possible on the EVM. It's really only possible within Cartesi, and that was a really cool use case for us to highlight. There's also huge savings on gas fees since this is a complex state that only runs inside of the Cartesi machine. The backend runs inside of the Cartesi machine the entire time, with all the computations, encryptions, and decryptions, and other game logics being replayed anywhere at any time, deterministically for anyone. So after the hackathon, since this is a fun game, we wanted to see if we could port more open source games inside of Cartesi's VM, kind of similar to what we've done with Werewolf, and use similar libraries that aren't possible on the EVM, and just see what we can do with it. And yeah, thank you for listening to our presentation.